Morning guys, it's May 4th. This is just going over the assignment from April 30th. So I gave you two quadratic equations and asked you to use the quadratic formula to find the two solutions for each quadratic. So this first one here, I created in the setup of having the negative b over 2a as its own ratio, then plus or minus, and then the square root of b squared minus 4ac over 2a on the right. So that way I can see that I have negative 3 halves plus root 5 over 2 and negative 3 halves minus root 5 over 2. So these are how I'm getting my two solutions. I simply plug them into a calculator, rounded to the nearest tenths place, and I got negative 4/10 and about negative 2 6/10. So that was pretty straightforward. Now the other one posed a little bit of a trouble because what happens is a lot of people lose track of their negatives. So I'm plugging in a negative 2 for my a value and a negative 3 for my c value, so make sure that you account for those negatives. I also did this where the entire problem is now one big fraction. So this would be the negative b plus or minus the square root of b squared minus 4ac all over 2a. And so then when I simplified, I get this, and then I had to plug into my calculator negative 10 plus root 76 divided by 4, and then negative 10 minus root 76 over 4. So I got x to equal about negative 3/10 and x to equal about negative 4 7/10. Now what I want to talk about today are these radicals right here. Now can this be simplified? And so what we're going to be getting into is how to simplify this square root, and then what happens if we have a negative inside. So first, let's talk about simplifying square roots. So what I'm going to do to simplify square roots is I'm going to find the factors of a square root. So before I do this, I'm just going to explain that, all right, if 24 is 2 times 3 times 4, because 2 times 3 is 6, 6 times 4 is 24. These are all considered to be factors of 24. Notice how I am multiplying them all together. That's how factors work. So if I turn this 24 into the square root of 24, I now have the square root of 2 times the square root of 3 times the square root of 4. And what I notice is that this square root of 4 is a perfect square. So that means that this square root of 4 becomes a 2. Because the square root of 4 is 2. These are synonymous. They are the same thing. So I rewrite to the square root of 2 times the square root of 3 times 2. Now these two radicals are not perfect squares, so I'm going to multiply the radicands together. That's the number inside the square root symbol. And 2 times 3 is 6. So the square root of 6 times 2. And this last step is a technicality. You always want to have the coefficients first, so 2 root 6, or 2 times the square root of 6. That is the simplified version of the square root of 24. Now what I have here are two more examples, the first one being the square root of 18. So what I'm going to do is I am going to break it up into two factors that I know. One is the square root of 2, the other is the square root of 9. Now, square root of 2 is the square root of 2. If I typed into the calculator, it would be 1.41, blah, 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 blah. The square root of 9, however, is 3. So I'm going to rewrite the square root of 18 to being 3 square root 2. Square root of 54. That's a little bit harder. The number's a little bit bigger. Maybe I can't think of a perfect square that goes into the square root of 54. So what I'm going to do is I'm just going to do something that I do know. I know it's even, so 2 must go into it. And 27 times 2 is 54. This I can't break up anymore, but the square root of 27 I can. I know that 9 times 3 is the square root of 27. So now I have the square root of 2 times the square root of 9 times the square root of 3. Well, square root of 9 is a perfect square. That is the same thing as 3. So I'm just going to move it to the front because we want those coefficients in front of our radicals. and I get 3 root 6. So that's the premise of simplifying square roots. Now, what happens if we are simplifying a negative radicand? So the square root of negative 9. Now, the whole thing about these square roots is that we have to have a perfect square because a number times itself equals another number, like 2 times 2 is 4, and the square root of 4 is 2. Well, what if we had the square root of negative 9? Well, 3 times 3 is 9, positive 9, and negative 3 times negative 3 is also positive 9. So there are not two numbers that I can multiply together to get negative 9. They have to be identical. So what we're going to introduce is something called a complex number or an imaginary number. Now, complex numbers are every number you could possibly imagine. A subset of complex numbers are imaginary numbers. You have imaginary and you have real. So this square root of 9, I know I like the square root of 9 because that's 3. And 9 times what is negative 9? Well, 9 times negative 1 is negative 9. And so I can simplify the square root of 9 into being 3. And the square root of negative 1, we use this letter I with a little tail on it. And so therefore, the square root of negative 9 is 3i. Let's see another one. How about the square root of negative 36? Well, that would be the square root of 36 times the square root of negative 1, which is 6 times I, so 6i. You want something more challenging? All right, how about the square root of, 12, negative 12. So two numbers that multiply to give me negative 12, well, I could do the square root of 3 times the square root of 4, and then times the square root of negative 1. Perfect square, I stays the same. 2i root 3. So take a look at this. I'm going to post a couple questions in Classroom as well. Try them out, and then tomorrow we'll probably try some more complicated ones. Good luck, guys.